bolts that'll, with springs or some kind of a mechanism that'll allow you to tilt the mirror like either sideways like this or up and down like this. It's got to be three-dimensionally tiltable to get it actually aligned with the whole optical system in 3 dimensions. Okay, actually when you look through this eyepiece focuser without an eyepiece in there against a bright sky, what you will actually see is a series of rings. And the first ring will be the outside of this mirror with no baffles in place. Say the first ring will be the outside of this mirror, and then the next ring will be the outside of this mirror right here, and the third ring will be the outside edges of this mirror. And if you get all 3 of these rings concentrically aligned up by the various tilting methods, then your optical system will be very accurately aligned. Like Texereau describes how to do that. It was actually fairly easy to do with my 20-inch Gregorian. The hard part I found, the really difficult part with my 20-inch Gregorian, was shifting this mirror back and forth here to get the focal point C in the right spot to where my eyepieces would actually reach it with the size of the focuser I had. So that's quite difficult to do, and as I say, you're going to have to be able to move this back and forth in very small amounts, and also, if necessary, to move this back and forth quite a bit. Because I say, I'm not just sure what the exact distance between point A and B is. And like I say, I could figure it out with a quadratic equation, but actually I tried doing that, and I had no success at all. My math teachers in high school would have killed me if they saw the mess I made of the mathematics trying to figure out the position of this mirror. It was hilarious. That's one of the funniest things I've done in recent memory as far as trying to make a telescope was concerned. It was a real mess. A huge amount of pages of algebra, and nothing good came out of it at all. So anyway, the best method, I think, is to focus on a distant object, like a distant chimney, or a distant street light, or a distant tree, something about a mile away at least half a mile anyway for a telescope that size, and just shift this mirror back and forth and make sure it's tilted correctly too. At the same time, you have to make sure it's tilted in the right orientation and also shifted the right amount longitudinally like this in order to get that in the right spot and obtain a sharp image. Okay, and then after you do that, you have to remember that each time you change an eyepiece, you're going to have to use your rack and pinion focuser to move the eyepiece up and down this way in order to get this image sharply in focus of the eyepiece. So you have to, like, after you get that all set with these mirrors, then you still have to focus each eyepiece individually by moving it up and down with some kind of a focusing device at the final focus area. So, but that's basically where it works. And I hope that I haven't rambled on too much, but I'll probably put the first video on probably today, and in the next day or two I'll put the second one on. Okay, but that's basically the way it works. If anybody wants to ask me any questions on the internet, like on my videos, like after my videos, there's a place where you can make comments. If you want to ask any questions, just go right ahead. I don't know whether I can say much more than that I've said anyway. I'm not sure I know that much more. One thing I can mention though, if you know the exact surface accuracy and figure, like the exact shape, that's what they call the shape of a telescope mirror, you can, Texereau in his book How to Make a Telescope has methods of using algebraic formulae to calculate the exact shape of this mirror to give a very perfect star image right at C. Really perfect. This method that I described using the 2 paraboloids will give a fairly nice star image there. It might not be perfectly sharp, but it should be pretty good. But if you want really, really good results, you almost have to grind and polish your own secondary mirror, which is what I did. And I think the final surface accuracy of my Gregorian, right at the final focus, the final wavefront error is approximately 1/6 of a wave peak to valley, according to my calculations. And when I actually use my Gregorian at up to about 600 power approximately, the star images are still very sharp, assuming that the atmospheric seeing conditions are good. And that's with a 20-inch Gregorian. I should mention this baffle tube right here for my 20-inch Gregorian is an 8-inch piece of sonotube that is yes, it's an 8-foot long, 8-inch diameter piece of cardboard sonotube like you'd use for pouring concrete. And this tube right here down at the bottom, I rolled myself using black paper, like construction paper that I would buy at Walmart or a dollar store. I rolled that myself into an exact shape and put baffles in it. And I've got all those lined up with special spiders and everything that hold them into place on my telescope tube. So, oh, I should mention one more thing too that's a little humorous. You see that big black blob right there? That big black blob right there is one of these arrows that I put in the wrong direction and it like blotted all out. I just blotted the whole thing right out. So you might say that I shot an arrow into the air, and where it landed, I know not where. Also, I should mention that there's one other advantage to my giant Gregorian telescope, and that is that the telescope looks so strange when you see it that all the local space aliens are afraid to come near it. So my risk of being abducted by a space alien is very low when I'm out using my telescope. There's almost no risk at all of me being abducted by space aliens when I'm out using my telescope, because they're all afraid of its appearance. So I thought I would mention that to you. So anyway, I'll probably have to include a third video to get all this in. But anyway, I'm going to stop right now recording. I hope this all is not too dysfunctional for everybody. Oh, by the way, please don't hesitate to let me know if I've made any mistakes. Okay, so I might have made an error in what I'm saying, but as far as I know, everything is okay. I should mention that a Texereau telescope is similar to this, except it is a convex secondary mirror between A and the big mirror right here, down about right in this area. And it's similar, but it's very difficult to figure this convex secondary mirror. This is much easier to actually polish and figure if you want to do it yourself, because you could test this mirror at the center of curvature, just like you would a normal Newtonian primary mirror. So with the Texereau's methods of testing a telescope mirror, and that's what I did when I made my Gregorian. Okay, so anyway, that's about it. I probably talked way too longer than I should have. I think it's going to take 3 videos to put all this in because I'm really overextending my time limit. But I wanted to make sure I got as much information conveyed to people as I could. And I would actually just make one more recommendation for the average amateur astronomer who wants a telescope that's fairly large, say up 10 to 12 inches and maybe up to about 16 inches or more, and want something that's easy to make and easy to use, or is just not too expensive to buy. Just buy or make a normal Newtonian telescope around f4 or f5, and with a normal diagonal and eyepiece holder, and use different powers of eyepieces and just enjoy using it. On the other hand, if you want to be adventurous and do something really strange, then make the Gregorian and try that out. I'm not sure how it would work absolutely with this paraboloid in place right here for the secondary mirror, but it depends on how well this paraboloid is made by the manufacturers, and how well the paraboloid here at the primary is made by the manufacturers, and also it depends on getting an accurately flat elliptical mirror right here. So, and also it depends to some extent on using a good eyepiece. Although I must mention that I should mention that the long focal ratio of f20 is much more forgiving of having relatively modest eyepiece quality. You could have an eyepiece right here, like that's really like very simple 2-lens eyepiece, like a Huygens eyepiece or a Ramsden eyepiece, or a simple Kellner eyepiece of some kind, and it will work very well. It will give good images. The same eyepiece used at an f4.5 Newtonian focus will give rather bad images. They might not be very sharp near the center of the field of view, and the images will deteriorate very badly out toward the edge of the field of view. That's another big advantage of having a long focal length, equivalent focal length telescope like the Gregorian, as you can end up with really good images with really low cost, simple eyepieces, some of which you can make yourself. So anyway, just out of surplus lenses or something like that very cheaply. So this design will avoid the cost of buying really expensive eyepieces. So anyway, that's what I've done with my telescope. One of my favorite eyepieces with my own 20-inch is a approximately 4-inch focal length Huygens eyepiece. And it gives approximately 145 or 150 power, and it works really well. It's got a wide field of view. It works really nice for low power views. One of the reasons I can use that is because my telescope is so big that this image can be fairly wide right here. Whereas in a smaller telescope, the angle is about this. It's got to be a bit narrower, right, to avoid having a huge central obstruction here. So, generally speaking, smaller telescopes generally have a like you have to be more like you end up with a higher power telescope. With my 20-inch, by using a giant eyepiece on there, I can get fairly low power. Not really low, but reasonably low. So anyway, I'm going to cut this off now. I'm pretty well exhausted, and here goes. I'm ending now. Goodbye, everybody. I just remembered one more thing I thought I would mention too, and while I'm here with the diagram more or less available, whoops, that is, it is possible, I guess I mentioned that there was a light baffle right here. If you want to have a telescope where you can sometimes use as a Gregorian and sometimes use as a Newtonian, you could have part of this baffle at least so that you could just remove it somehow. Just slide it off or unscrew it or something from the back part of the baffle, and then add a Newtonian diagonal right here, which would be a flat mirror like this, shaped like that, and then it would divert the light out there before the starlight, before it even reached this mirror. So just once in a while, if you want to use your telescope as an ordinary Newtonian, you can just remove part of this baffle and then somehow add, like, you'd have to make sure it was good, well solidly fastened in place. Put a Newtonian diagonal in there with an eyepiece focuser right here like this. It would bend the light this way. And then use it for a while. And then when you wanted to switch back to the Gregorian, you simply take this Newtonian diagonal away and put the light baffle back for the Gregorian. And then you could have both telescopes in use, from time to time as needed. Sometimes you might want to get a really wide view of a comet or some large nebula or star cluster or something. Then you could use it as a Newtonian. And if you want to observe the planets or the moon or a small planetary nebula or a globular star cluster at really high power, then you could switch back to the Gregorian. So, and also to switch back to a more comfortable observing location for the eyepiece, especially if you have a really large telescope. So anyway, I thought I should add that just to mention that you don't have to use either design permanently. You could actually make it, if you use some ingenuity, you could actually create a telescope where you could switch back and forth between the Newtonian and the Gregorian form. So anyway, I'll say goodbye again. Hope this will all fit in the YouTube videos. If not, I might have to go to a fourth video. So that would be okay. It's feasible to do that, I guess. I might just do that anyway. Goodbye.